So what we're going to do is we're going to show, we're given some working, we're given PQ over PR equals cos QRP, and we've got PX over PQ cos QRP, therefore that equals that, and it gives us an answer of that there, right? We have to do the same working, but for this here. Okay, so it's like they've given us the answer to that, okay, but it's a different answer. So we need to work this out. I'm just going to briefly explain what each of these means, okay, and then so that you understand what this is, okay. When you normally do a cos or a tan or a sine triangle, you use adjacent, hypotenuse, and opposite, right? So if we're using PQ and PR, which triangle are we going to be using? Which triangle? Or which so here's PQ. This one's here, that side there is PQ. There, yeah. And this side here is PR, right? So, and they've given us that angle there, which is QPR, right? Yep. Yeah. What side would I label that, if that's the triangle that I'm using? What side is that out of adjacent, hypotenuse? That's the adjacent, yep. Everybody happy with that? Yep. And this one here is the what? Hypotenuse. So if I was to work out any of those things, how would I write it? So let's, for example, say I gave you that A, pretend that adjacent was 5 metres, and I gave you that was 40 degrees. How would I work out H?
You just put an X.
Yeah, I'll put an X there, so that's my X.
Just get cos 40.
Yep, and you
5 of X.
exactly. So it'd be cos 40 equals the adjacent over the hypotenuse, so 5 over X. Right? And could everybody work that out? Even if you don't see that straight away? Caden?
Yeah.
Andre? Good? Okay. So that is what they're actually writing there. They've replaced the 5 with PQ. They've replaced the X with PR. Okay? And the cos 40 is the angle. Did everybody see that? Yeah? Okay. So, does that now make sense what they've written there? In terms of that line right there. That line. That's the same as that there, but with no numbers. Okay? Yes? Good? Good? Okay. This line here is actually the same sort of idea. I'll just erase all of that when I find my eraser. Where is it? No, I'll be under pen. I'll get rid of all this. When it wants to erase, it's not going to erase, is it? Oh well, we'll just leave it there. If I'm going to use that one there, instead of PQ and PR, I'm now going to be using PX. So there's PX there, and it's the same thing. PX over PQ will mean that the triangle I'm actually thinking of now is this one here. It's the smaller one. Okay, so PX in this case would be the adjacent of that angle, the same angle there, 40 degrees. It's now written in brown. That would be the adjacent, and this one would be the hypotenuse, not that one. Does that make sense? And so it's the same idea. It's the adjacent divided by the hypotenuse equals cos of that angle. Happy? Mm-hmm. So they just write both of those things, which are both true. This step here is a little bit trickier. If you imagine that this cos QPR and that cos QPR, they're the same thing. See, cos QPR. So I can actually say that this thing here is equal to that thing there, because they're both equal to that thing there. Right? Right? Right or not right?
I'm not sure.
You're not sure? So what I'm saying is that, see the cos QPR? Mm-hmm. That's the same as that thing there. So this equal means they're the same thing. That equal sign means these things here, that thing and that thing, they're the same thing, right? So I can actually replace that cos QPR with anything that it's the same as. And that cos QPR is the same as that thing there. It's the same thing. They're equal, they're the same thing. So I can replace that with this here. because they're the same thing. Okay, so this line of working is just PQ over PR, that thing there, those things are the same, equals this thing here. Does that make sense? Yes? Yep. And then you do some fandangled algebra, which I don't actually need to show you how to do, and you get to that answer there. What they want us to do is they want us to write the 3 lines of working that precede that come before that, but for that one there. Okay? Can you see how that thing there is similar to that thing there? Like in terms of the form, it starts with a squared thing and then is a thing times a thing. That little dot there, by the way, means times. Happy? Okay, so I'm actually just going to write this thing here as my answer. Okay? And I'm going to work backwards up, or work backwards. So QR squared equals RX times PR. Right? Okay, so that's my answer. I'm going to work backwards and up. Okay? So I'm going to write just the fraction things, and we're going to see if we can figure out what goes on top and what goes on the bottom. So those 2 lines here are fractions. Okay? I need to write the equivalent of that, but for this one here. Can anybody see what might go there, or there, or there, or there? Can anybody see that?
Yeah, I can.
Yeah, I know you can, Daniel, because you've done it before. The other 3? It's a really hard question.
Would,
What do you think, Ben?
would RX go there?
RX go there?
Yeah,
Why do you think RX goes there?
because the PX is
Yep.
there, and then that's the first.
Yep, so that's PX and that's RX.
Yeah,
So PX goes up there,
yes.
therefore RX has to go up there. Does that make sense? So it's going to be RX. It's an awful R, but we'll just deal with it as an RX. What's going to go where else?
PR go there.
PR goes here.
Yeah.
The reason PR will go there is because PR for that one goes there, and this the thing that goes in that slot will also go there.
Yeah.
Right? Happy? What is going to be left? And I'm going to ask you, Andre, see if you can figure it out. What's going to go there and there? Based on this thing and this thing.
What about the other sides of the
Yeah.
triangle?
So what's it going to be?
Not sure.
You're not sure? So I'll just go through it again. Just so I know you can see it, Liam. So that's QR. The reason it's QR, just look at this formula here. We're working back towards this. The PR goes there. The PX goes there. The PQs go there and there.
Oh, okay.
Okay? The PRX has to go there, just like the PX goes there.
So the QRs would be here and there.
Yeah, the QRs are going to go there and there. Make sense? Really tricky, guys. Really tricky. QR. Now we're going to work backwards. One more step. Okay, one more step. We've got to come up with these 2 here,
Which is easier.
which is slightly easier.
Yeah.
Slightly easier. I'm going to try and erase it again, see if I can. Oh, my goodness. Let's see if that... Oh, look at that. It worked. Hurrah. Boom. Okay, perfect. What we were dealing with before is we were dealing with these triangles in here, that one there, that smaller one. Looking at those things there, the QR is that distance there, RX is that distance there, and PR is that distance there. Which sort of triangles are we going to be dealing with in this one? So QR is that one there, RX is that, and PR is that one there. We're not going to be dealing with this side. Which side are we going to be dealing with? Anybody see? This side here, right? We're going to be dealing with that side there because we've got a QR, that's that, and RX, which is this one here. So that's essentially like that small triangle. Okay? So that suggests that we're going to have our angle as that one there, as opposed to the last time when we had the angle in here. Okay? So that's angle what?
QRX.
QRX. So instead of QPR, we're going to have QRX. Okay? So I'm going to write that. I'm going to write this line here first. Okay, so I'm going to write an equal sign, my equal sign, And instead of cos QPR, I'm going to have, just like you said, guys, cos QRX. Okay? The next thing I'm going to do is I'm going to have, I've got to figure out which one of these goes there. Okay? Can anybody figure out, based on these fractions here potentially, what's going to go there? Anybody see?
B. Would be RX.
Mhm.
Over
QR?
QR.
QR, it is. It's that one there, okay? So there are two ways I can figure that out. Either I look, the PX and the PQ goes there, so therefore it must be this one here that goes there. It's not this side, it's this side that goes there. Okay? I could think of it like that, or I could think, well, if I'm trying to figure out again, if it's cos QRX, cos of that angle, and I'm going to be dealing with a PX, which is that one, sorry, this triangle here, then it must be the adjacent over the hypotenuse, because I'm dealing with cos. Must be adjacent over the hypotenuse. So it's going to be that one there, that's the adjacent. If this triangle here, that triangle, that's the adjacent, and that's the hypotenuse. So it must be RX over QR. Okay? Okay?
Yep.
Yep, okay.
Yep.
Cool. This is super, this is the hardest excellence question I've ever seen for these, by the way, just so you're aware. RX over QR. Can anybody just see straight off what the next line's going to be above?
Would be the other fraction.
The other fraction, perfect, so QR over PR equals what?
Would it be the same as before?
The same as before.
RX over.
No. See, what I'm essentially writing is I'm writing this one up here. So it's the other fraction, so this one here, equals the same angle as the one I've got below, that angle there. Okay? Do you see that, Liam?
Yeah.
And that's the answer. So what they wanted you to do is they wanted you to write the same sort of thing here, but for that answer. Have a look at it. Any questions on that? No? No?
So it's just writing exactly what I've got here.
Yep, writing exactly what they've got there, but for that.
Just change it up.
Just change it up.
So would you, in
Just
the
change the
exam, would you, like, prefer like to go backwards, like what you've done?
Yeah, or if you could figure out what this meant, you could start from the beginning. But I think it's easier to go back up in this case. Okay? Happy?